Properties of matter basically fall into kind of four categories. You have extensive, intensive, physical, and chemical. Now, to begin with, remember basic definitions of matter. Anything that has mass and occupies space. So, has mass, volume, etc. The main thing I want you to notice here is all of the different particle diagrams that we're using to represent the types of matter. So we have individual atoms, we have the same atom bonded together, so those are molecules or a particle diagram of a diatomic element. Here we see a compound, because you can see the different atoms that are bonded together, and here we have a combination of all of the above. So ultimately, when we deal with matter, we either have atoms, the building blocks, we have elements, we also see this as the diatomic as well as the atoms, and then we have compounds. And all of this type of matter then will have properties. And all of the properties allow each type of matter to be distinguished and identified. So, types of properties. First and foremost, we have what's known as intensive or extensive. And the main thing you need to remember about intensive is it's independent of amount. So, density, anything that's identifying. If changing the amount changes how much you have, for example, like mass, that's what's known as an extensive property. It depends on the, oops, that was poor, wasn't it? Let's undo that and try again. Let's try a highlighter. Extensive depends upon the amount. Intensive is independent of it. So examples of anything that changing the amount changes the property itself, that's going to be mass, that's going to be volume, that's going to be the amount of energy when I burn it. Something that is independent is density, boiling point, conductivity, temperature. Temperature is independent of the amount I have, etc. So those are your two classes of properties. Now, in the next few slides, interspersed amongst this presentation are questions for you to answer. What I would like you to do is pause, write the question down, write your answer. We're going to discuss the answers in class. So, first question. Be sure and pause the video and then write your answer and then move on. So I hope you chose your answer. We're going to discuss the possibilities in class tomorrow. Next idea then, go to our physical and chemical properties. Now, physical and chemical properties are huge because it is this difference that both allows us to distinguish different types of matter and actually ultimately to separate them out or produce new things. Now, the main thing to remember about a physical property is keep it simple. Its appearance. Okay, when we talk about a physical property, usually I can describe it by looking at it. Okay, that's a white plastic chair. I hold a penny in my hand and it's kind of got a coppery sheen to it, etc. You can describe the mass, you can describe what it looks like, you can describe whether it's shiny or dull, you can describe whether it's brittle or ductile, meaning you can stretch it into a wire, etc. So anything that simply changes the appearance or addresses the appearance we consider a physical property. Now, chemical properties, on the other hand, we typically only see during a change. Literally, it has to change into something else. And these are things that we associate like flammability, corrosiveness, reactivity. Not everything behaves the same with everything else. For example, if I put sodium, metal, and water, it's going to be a highly explosive reaction. But if I put sodium chloride in water, it simply dissolves. So chemical properties are unique to each substance that we deal with. Now, if I can have the property, I can have the change. So a physical property will produce physical changes. So physical changes are changes in appearance. Okay, if I have water and I produce steam, oops, there's my steam cloud, it's not very pretty. I can have a glass of water, okay, or I can have a cube of ice. It's still all water. all that's changed is the physical appearance of it. So phase changes, or changes in state, are physical changes because it's still ultimately water. It's still one oxygen and two hydrogens. Whereas a chemical change, because I get something completely different, I see something that wasn't there before. And all chemical changes have three common identifiers. The first, we see the production of a gas. We see the production of a precipitate. Remember from your freshman year, precipitates are substances that when you mix two solutions together, you have something solid that seems to pop to the top, it floats to the top or sinks to the bottom, but there was nothing solid in the solutions before you mixed them. And then the last thing is we associate a color change with a chemical change. So if I had a clear solution and a clear yellow solution and I suddenly get something dark red, that's a color change. Something's present that wasn't there before. Now, in addition to changes, any kind of change in matter, whether it be a physical or chemical change in matter, there is always an associated energetic change. In other words, it takes energy to produce the change, whether it be physical or chemical, it doesn't matter. Now, the main thing you have to remember here, though, is since both physical and chemical changes involve changes in energy, a change in energy is not indicative of one or the other, but it's associated with it. And it kind of makes sense. We know we have to take energy away if I want to freeze water. I know I have to add energy to make water become steam. And the same thing is true for some chemical reactions. We'll have to add energy for them to proceed. We'll have to, literally sometimes some reactions will, to make it proceed, we actually have to take away energy. So there's always a change in energy associated with any change in physical or chemical properties. So if I have a new substance, it has new chemical and physical properties, there was an energy change associated with making that substance, etc. All right. Now, there's a couple more questions. So again, here's your next question. You might have to make this a little bigger. I apologize for it being so small. Pause the video, answer your question, then move on to the next one. Here's the next question. Again, pause it, answer the question. We'll be reviewing these in class tomorrow.